All right, good morning, everybody. It is December 3rd, and it's a Thursday, and today's PowerPoint is going to be about how we can find out the age of rocks so that we can also find out the age of fossils that we find that archaeologists and paleontologists and scientists find out there. So the other day, or yesterday, when we talked about those 5 different things that we look at for the fossil record, or for evolution, we looked at fossils. So that's what we're going to be looking a little more closely at today, and how we can find those ages. Okay, so some of this stuff is highlighted for you to take notes in your notebook, but feel free to add more so that you understand and you can go back to your notes. Of course, this will always be up, so you can go back and review it at any time. And then before we get started, I also want to remind you that you need to go and do your attendance. We did really good yesterday. We only had 13 students on the hybrid model that did not go and take their attendance. So let's beat that today, okay? All right, so here's the PowerPoint. It's ways to tell the age of a rock. All right, so we have relative dating, and that's one way that scientists can figure out where to place rocks and fossils in the geologic history. Okay, so they create a geologic timescale, and it helps us provide placement for these things. But it doesn't tell us the true age. It is just relative to what you're comparing it to. Relative dating principles. There's 3 of them. Okay, the law of superposition, which we talked about last year. If you think back to way back in the beginning of 7th grade, and we did that earth science, and we were talking about layers of rock and oldest to newest, and then we had, that's the law of superposition. The next one we have is called the cross-cutting law, which we touched upon last year as well. We talked about when things happen to those layers, they get disrupted in some way, and that's the cross-cutting law. And then the last one is the law of inclusions, which is new. We haven't talked about that one, so we're going to look at each one of these. Okay. Okay. So the first one is the law of superposition, and you're going to remember this from last year. If we're talking about layers of Earth, and we're on the Earth in a specific location, and nothing has happened to it, so it's undisturbed, and you can see the strata just continues across and there's no disruptions, then you can say that the oldest layer is on the bottom, and as you move your way up, you get younger and younger. Okay, so then you get to the top, and that's the layer that we are on, and that is the youngest. So here's a good analogy for the law of superposition. The locker idea, which I got to experience this last year when we cleaned out all your lockers. Some of you had quite a bit of strata in your locker, and of course the stuff at the bottom was the oldest and grossest. So we found some old food and jackets and pencils and everything like that. So that is a good example that you can apply to your own life. That you have the oldest on the bottom, and the newest stuff is on top, right? So you're just throwing in your water bottle, throwing in your binder, and lots of loose papers. And on top, that's the youngest. Many of you are more organized than this, and if I saw a textbook in that condition, I'd make you pay for it. So anyway, that's a good little analogy to think about. Here's another little thing to think about. So we have these layers, and as you go down, you can see at the very bottom in layer number 1, those are those trilobites that we talked about last year, and then it moves on up, and you can kind of see the evolution of things. And then at the very top, you can see somebody walking their dog, and that is the youngest layer. Okay, so before we move on, I also attached a document on your calendar today, and that's this one right here. which is a bunch of letters that kind of stand for different types of rocks. And if you have a printer and you want to do this and cut it apart just like you see here, you can go and do that, and you can just pause here and go and take care of that. If you don't want to print it out, or you can't, you can just write these letters down as we go through this. It's kind of like a little puzzle that you're going to get to kind of think about and see how these layers come on top of each other. Okay, so if you want to go and get this, you can. If not, you can just use a piece of paper and write the letters down as you go. You just need a blank piece of paper. Okay, so here's how you do it. The cards with the letters T and C is on the bottom, or the oldest layer. So just go ahead and grab that one, or write this on the bottom of your paper, TC. Okay, and the rest of those cards are going to be built on top of it. Okay. So you're going to look for a card that has either a T or a C written on it for its second layer. So since this card has a common letter with the first card, it must go on top of the first card. And this second layer is younger than the TC layer. Okay? So what you're going to do is you're going to continue to sequence the remaining cards using the same process. So go ahead and you can pause and try to figure out the puzzle and build it. It's going to go right. It's going to keep going up and up and up. So just clear space so you have room to do it, or write it on your piece of paper. Alright, so here we are with what it would look like, and you can do this. And while you're thinking about that, I wanted to tell you that if you're watching this and listening to me, I so appreciate it, that you're logging on and you're getting into these videos. This takes time for me to do, and of course I know you guys can just mute me and look at the slides. So anyway, if you're listening, you can email me, or you can text me. Just make sure you tell me who you are, both in the email and the text. Please tell me your favorite breakfast item that you would love to eat. And if you answer that question today, I'm going to give you a raffle ticket. And that raffle ticket is going to go into a big bin. We're going to be putting your name in there every time you come to a Zoom. Every time you complete a assignment, you're going to get a raffle ticket. And when we all get back together after the holidays and after you're able to come back, we're going to take some raffle tickets out, and you're going to get some big prizes. We're not talking donuts and bags of chips. We're talking about big ticket items. So passes maybe to Wild Waters or something substantial. So this is how much we're serious about this. So if you get this, if you're listening and you can tell me your favorite breakfast item in an email or in a text, I'll give you a raffle ticket. Okay, so let's move on. The next one would be AU. So now you're looking for something with a U in it. And a BN. And what would come next? Something with an N or a B. OXD, and then the last one would be DM. Okay, so then if we put these in order from youngest to oldest, on the right side there, that is the order that you would see. Okay, so that's just a good little, tactile thing to do to kind of think about this and hopefully remember down the road. Okay, so relative dating principles. This is the next one. It's the cross-cutting law, and this is something we talked a little bit about last year, talking about something that disrupts that strata. So you have these nice layers that you can see, and then something comes along and interrupts it. Could be a fault or some sort of intrusion where something is pushed up or pushed down. Okay. Anyway, this feature, anything that cuts across a body of sediment, the rock is younger than the body of sediment or rock that it cuts across. So You can see that they've labeled it. So anything that cuts across a fault line or an intrusion of some sort is going to be younger than anything around it. So here's some visuals to think about. We do have some nice strata out there, but there's lots of interruptions with earthquakes and tectonic plates and things like that. So if you look closely at the diagram there, you can see there are faults and lots of things that are created by those volcanoes. Okay, in that middle picture, you can see that really dark rock coming through. That is going to be younger than the stuff around it. Okay. Okay. Law of inclusion we have not talked about. This is that third one. Okay. If you think of inclusion, think of including people, including things, and so that's a good way to remember this. And so what we're talking about is rocks that are surrounded by other rocks are going to be older than the rocks that are around them. So like we're talking about little rocks and then a bigger formation is around it and contains it. That's going to be, the smaller rocks are going to be older. Okay, so we have an example here. The carstensite rock is kind of coming around that granite. You can see little pieces of it there. And so we can say that the granite is older than the carstensite. Okay? All right, in this video, she just explains the law of inclusion in a natural setting. So this one is not very long. It's only about 50 seconds. So we're just going to go ahead and watch it together.
I'm standing next to a volcanic breccia in the Clarno unit of John Day Fossil Beds National Monument in Oregon. And this volcanic breccia nicely illustrates the principle of inclusions, which is a rule that we can use to help us establish the relative age of rocks. The relative age being which one's older, which one's younger. And so if we look at this rock, we can see it has these large clasts or inclusions of other rocks inside of it. And so these inclusions have to be older than the rock itself that is supporting them, because these clasts had to exist first in order to get incorporated into this volcanic matrix when it was erupted.
Okay, so just to review, we went over the law of superposition, the law of cross-cutting, and the law of inclusions. You're going to see more of this today in the form that you're going to be doing. So use this to kind of go along with that. And if you have any questions, I will see you on the Zooms.